Okay, so today we will talk about some exercise about complete the square. So here's some examples. V squared minus 8v plus 14.5 equals to 0. So remember, complete the square, basically we are looking for a b. The perfect trinomial, a squared plus 2 times ab plus b squared equals to a plus b equals to a plus b squared. So that's the formula that we based on. Of course, there's a subtracting version, which is a squared minus 2ab plus b squared equals to a minus b squared. Okay, so now take a look. The first step is we move the constant term to the right. So let's subtract 14.5 on both sides. So v squared minus 8v equals to negative 14.5. So now we have a squared, the first term, and second term, which is 2ab. So now we need to add b squared on both sides so that we can construct a perfect square. So b squared equals to what? So b basically is equals to half of the number here, which is half of negative 8 squared. That would be our b. So we need to add it on both sides. Okay. So we have a plus our b, which is negative a plus 2, which is negative 4, square equals to negative 14.5. Oh, there's no square. Negative 14.5 at negative 4 squared, which is negative 14.5 at 16. So I have v minus 4 squared equals to negative 29. Now take square root on both sides. We have a v minus 4 equals to positive or negative. Remember, when you remove the square, you will have a positive result and negative. So now I know that we all think about, hey, there's no negative sign under the square. But remember, there's a complex number, which is negative 1 equals to I squared. Okay, so that means negative 1 equals to square root of negative 1 equals to I. So that means this function equals to square root of 29 times I. It's the complex number. So our v has two possibilities. Either is 29i plus 4, or v equals to negative 29i plus 4. Because we have positive and negative. So now let me recap the steps. So if you have a number look like, hey, x squared plus mx plus some constants. Let's say constant means just the number. I'll just put constants. Constant equals to 0. The first step, if you want to construct a perfect square, the first step is you want to remove the constant to the right. So we will have x squared plus mx plus, equals to negative constants, whatever constant that is. And then in order to construct a perfect square, we need to add half of the number m and then square on both sides. So that from the first 3 terms, the left 3 terms, they can construct a perfect square, which is x plus m over 2 square equals to whatever constant it is plus m squared over 4. Okay, so I'm going to give you another examples. So let's do this one. I have x squared plus 10x minus 57 equals to 4. The first step is you want to remove all the constants to the right side. So that I want to add 14.7 on both sides. I have x squared plus 10x equals to 61. And then we want to add half of this number. Just be careful about the negative sign. If there's negative sign, you need to add the negative sign as well. So I want to add half of that number square on both sides. Okay, so now we can construct a perfect square. The first three terms equals to x plus 10 half equals to 61 plus 25, because 10 over 2 is 5, 5 squared is 25. Okay, so this has become 5. I'm going to change it to 25. And now let's simplify it. So we have x plus 5 squared equals to 86. So when you take square root, I have x plus 5 equals to positive or negative square root of 86. So x either equals to a positive 86 minus 5, or x equals to negative 56 minus 5. Okay, let me give you the last examples. What if the function looked like this? X squared equals to negative 10x minus 29. Okay, so this one is, you already have the constant term on the right. So which one you want to move to the left? This one, right? Okay, so what we will do is we add 10x on both sides. And then follow what we did earlier. And then we add half of 10 squared on both sides. So that I have x squared, not x squared, I'm sorry, x plus b squared, which is 5 squared equals to negative 29 at 25. So I have x plus 5 squared equals to negative 4. And then take square root on both sides. I have x plus 5 equals to square root of negative 4. Remember, a negative, if you want to separate the negative, you can read it as negative square root of negative 1 times square root of 4, right? And then square root of negative 1 equals to I. So we have square root of 4, which is 2. Oh, I forgot something. Remember, when you move the square root square aside, you take square root, you need to have a positive and negative. So that I have x plus 5 equals to, maybe we don't need this anymore, equals to positive or negative square root of 4 equals 2, right? So basically this is 2i, positive or negative 2i. So x either equals to positive 2i minus 5, or x equals to negative 2i minus 5. Okay, so that's it. Let me get another examples. A harder one, that when the a is not equals, when the highest term is not equals to 1. So if we have something like this one, 2x squared plus 63 equals to 8x. First of all, we need to remove the term to the right place, which is you move the ax here and move the 18.3 to the right. So I have a 2x squared minus ax equals to negative 63. Okay, so in here, what should we do next? You want to make this term become 1. So what you can do is divide the 2 on both sides. So the next step is you want to divide it by 2 on both sides. So they both divided by 2. I have x squared minus 4x equals to negative 63 over 2. And then what's next? You just need to add half of what? Negative 4. So I have x squared minus 4x. You want to add, remember, you need to add it on both sides. Don't forget the negative sign. Okay, so the first 3 terms, they can construct a perfect square, which is x minus 2. Because negative 4 divided by 2 is negative 2. Square equals to negative 63 over 2 plus, this is not hard. You think about negative 2 times negative 4 half, which is positive 16 over 4. And then, how do you calculate the fraction operation? Since they don't have a common denominator, we need to find the common denominator for them, which is 4, right? You times 2 on the top and bottom. I have negative 126 over 4 plus 16 over 4. So I have x minus 2 squared equals to negative 110 over 4. Now you can take square root, or you can simplify first. Let's simplify it. So this is equal to negative 55 over 2. Now we can take square root out. We can take square root on both sides. We have a positive and negative, negative 55 over 2. You can pull the I out, which is x minus 2 equals to positive and negative square root of 55 over 2 times I. That's how you pull the square root of negative 1 out. Okay, we still need to rationalize the denominator. What do you mean rationalize? So in a fraction, if you see something look like square root of 2 over 5, rationalize means you can't have a square root of 2 in the bottom. You can have a square root in the denominator. What you will do is you square root 2 on both sides, so that means you square the bottom. So this is become 2. So on the top, you will have 5 times square root of 2. That's similarly to other questions too, such as square root of, 4 over square root of 11. You can keep the square root on the top, that's fine, but we don't want the square root in the denominator. So that I have square root of 11 is times square root of 11 on the top and bottom, so that you can rationalize. The bottom will become 11, the whole number, instead of with the square root. You can have square root in the top. So in this case, what do? Is you try to square root of 2 on the top and bottom. So basically, okay. So where x minus 2 equals to positive and negative square root of 110 over 2 times I. So x either equals to positive square root of 110 over 2i plus 2, or x equals to negative square root of 110 over 2i plus 2. So this 2 is the solution. Okay, let me know if you have other questions.